Hi, everyone. Welcome. So I am Professor Reiter, and I am delighted to welcome you to the Ocean and Water Pollution panel today as part of the VGEL Symposium. Today we'll be diving beneath the surface of the water alongside our panelists and uncovering pollution, both the pollution we see and unseen pollution as well. In this panel, we'll hear from lawyers, scientists, and marine resource managers working to rid our collective waterways from pollution and its harmful impacts. So for the sake of time, I'm going to stop here and let our panelists speak. I'll tell you the order that we're going to go into, and you can reference their bios thanks to the student organizers at VGEL. I've just asked each panelist briefly to talk about their line of work, what they do, because I think that will be interesting for students that are watching. And interestingly, because all of you work with pollution in different ways and in different bodies of water, what constitutes pollution within your line of work? So first we have Ben Eichenberg. He's a staff attorney for the San Francisco Baykeeper. Then we'll have Michael Stocker, the executive director of Ocean Conservation Research. John Groveman, the Policy and Water Program Director at the Vermont Natural Resource Council. And finally, Jackie McGarry will bring us home as the manager of the Global Ghost Gear Initiative at the Ocean Conservancy. All right, go ahead, Ben.
Thanks so much, Professor Reiter. As you said, my name's Ben Eichenberg. I'm a staff attorney with San Francisco Baykeeper. So background on Baykeeper, it's a nonprofit environmental organization. Our mission is to defend San Francisco Bay from the biggest threats and to hold polluters and government agencies accountable for to create healthy communities and help wildlife thrive. Our team of scientists and lawyers investigate pollution via aerial and water patrols, and we strengthen regulations through science and policy advocacy and enforce environmental laws on behalf of the public. Thank you again for the introduction, Professor Reiter. I'll do a little more in depth. Just on me, I started law school, not so sure whether I want to do environmental law or more electronic information systems, but there really wasn't any, there really weren't any jobs in the electronic information system nonprofit sector. There's pretty much, at the time anyway, there was just the Electronic Frontier Foundation. So I decided to focus on environmental law. I wanted to do public interest law, so that's why that was my focus. But before starting work, I did a Fulbright in Norway in public international law to round that out, and then did some consulting and think tank work right after that before jumping into a public interest private law firm. And from there went to San Francisco Baykeeper. At Baykeeper, I focus on litigation. Baykeeper uses litigation strategies to enforce environmental laws and regulations. Mainly we use, my focus is on the Clean Water Act. So maybe I'll give a little background on the Clean Water Act and why it's so important. It's a huge success story, one of the most successful environmental statutes ever. There's still a lot of problems and a lot of things it hasn't accomplished. Lakes, reservoirs, and ponds are impaired for water quality standards. Up to 70% of them are still impaired for some water quality standards. 31% have degraded benthic microinvertebrate communities. Indicators of lake health are continuing to get worse. Rivers and streams, over half fail to meet state water quality standards. Only 28% are in good condition. A lot of them have excess nutrients in them, bacterial levels that are a threat to human health, mercury in fish tissues. In wetlands, more than 50% of wetlands are not in good biological condition. 1/3 are in poor condition. And then bays and estuaries, 80% found to be impaired for some water quality standard. For instance, the Gulf of Mexico's dead zone, I think 2017 is the last I have data for it, is the largest measure since surveying started in 1985. So that dead zone is about the size of New Jersey right now. So all of these issues are things that we face in our watershed in San Francisco Bay. We have, lots of rivers and streams that are tributaries with wetlands. Obviously, it's a bay. So our program priorities are to address the biggest threats to the bay. And we've categorized those as preventing oil disasters, restoring fish and freshwater flows, rewilding the shorelines, holding industry accountable, keeping the bay blue, tackling toxic hotspots, curbing urban slaughter, protecting the bay's bottom, and building resistance to sea level rise. All of these are influenced by water pollution. We use litigation tools for many of them. We try to assess which tools are best to use to address each of those program priorities. Primarily, what I work on is holding industry accountable through, I use my main tool there is the citizen supervision of the Clean Water Act. So I'll give a quick background on some of the points of the Clean Water Act that are relevant here, just in case people aren't familiar with it. The Clean Water Act, the basic prohibition is that there be no discharge of pollutants into waters of the United States without a permit. Clean Water Act Section 502 defines discharge of a pollutant as an addition of a pollutant from any point source. The definition of pollutant is very broad, so it can be salt, it can be temperature, it can be anything that wasn't in that water to begin with. And a point source is also defined there as any discernible, confined, and discrete conveyance. So that's any kind of pipe, channel, anything that channelizes the water counts as a point source. So basically, any discharge of water that contains pollutants has to have a permit, and we're looking for either permit violations or facilities that don't have permits that are polluting the bay. One of our tools in California for doing that, for assessing that, is the general industrial stormwater permit issued by the state of California, and that covers, because under the Clean Water Act, not only do you have the point sources of sort of pipes and discrete conveyances, but you also have any kind of industrial facility that has stormwater coming off of it, that counts as a point source. And so that means they have to have a permit. That means all industrial facilities in California have to have some kind of a permit for the stormwater that comes off of their facilities. And under that permit, they have to monitor. They have to monitor for what pollutants are in the stormwater that comes off of their facility, and then they have to publish that data and that monitoring publicly. So what we can do then is we can go through and we can look at what the results are of that monitoring and assess how different industrial facilities are doing with their compliance. That gives us the opportunity to assess what the worst industrial sites are around the bay, and then to decide whether litigation is a good strategy for bringing them into compliance. See, one of the, some of the pollutants we're looking at coming off of these industrial sites are things like what's called chemical oxygen demand, iron, aluminum, copper, zinc, nitrogen, things like that are sort of the main pollutants that are measured. And then we also, all of those pollutants are sort of categorized with numeric action levels, which is a tool that helps the industrial facilities gauge their effectiveness in preventing stormwater pollution. And it also gives us a benchmark to measure their compliance with the industrial general permit in California. So so when we find a facility whose self-monitoring shows that their stormwater pollution coming off of their site is bad, is much higher than those benchmarks, then we can do a further investigation. And what we do to do those further investigations, we use sometimes we do our own sampling. Sometimes we'll go in. I've gone in on a kayak before to take stormwater samples of water coming off of industrial facilities, and now recently we have a drone that we use to take pictures and to monitor where stormwater might be coming off a site and to further investigate the site. So that can be pretty exciting. The kayak, I see, I do have some, I'm going to try to do a share screen and we'll see how it works. Because I think it's going to be more interesting for everybody if we try to do it this way. And it's hard to tell what's working or not, but hopefully you're seeing San Francisco Baykeeper's screen. And then next slide, this is a picture that I actually took taking a stormwater sample underneath during a huge rainstorm. Wind gusts were probably 20, 30 miles an hour, and I was trying to kayak through this driving rain into this industrial facility and then slide underneath their pier where water was pouring down out of there. Basically, all this water was being collected up in their facility and then put into drains and coming out down through the pier straight into the bay. So we slid under there and took these samples and sent them to a lab to try to figure out whether they were doing a good job or not, keeping their stormwater runoff clean. So that's the kind of kayak stuff that we do. And then we also have the drone. This is our investigator Cole out piloting the drone. And it's been really handy because what we can do is we can look at the different gradients in the land of an industrial site, so we can tell, but even when it's not raining, we can tell where the water might be flowing and things like that. So it's been a great tool. So one of the cases that I worked on a couple of years ago was a circuit board manufacturer, which was largely indoors, but so this guy, they publish these documents, and you evaluate the map and you try to figure out where the water is coming off and what different types of management practices they might do to sort of keep their stormwater in better condition. And just step back a minute, that industrial stormwater is a major source of pollution. It's quite dispersed. So each site, one particular site like this circuit board manufacturing site might not contribute that much by itself to the overall pollution in the bay, but combined with all of the industry around San Francisco Bay, it creates quite a bit of pollution. Maybe the largest source if you think about it that way. So our hope through these cases is to sort of bring all these facilities into compliance with the industrial general permit and to reduce that single largest source of pollution into San Francisco Bay. So with this facility, I think we ended up settling. We settle all of these cases mostly because once you have that self-reported data and you're going before a judge, you don't really, there's not really a lot you can say, when you took the samples and it's your pollution and it's clearly over the benchmarks that EPA has published. Lawyers can always find something to argue about, but nobody ever really wants to go to court under these kinds of circumstances. So what we do is we settle for pollution remediation. So that what they did here is I think they installed some better air filters on their sort of rooftop. A lot of, because of the type of circuit board stuff that they did inside, they had to sort of vent these harmful industrial processes onto the roofs, which then got washed down into the stormwater. So they had to put better vents up there. Then they had to do some sort of treatment system for all the stormwater coming off of the site. And then we also get supplemental environmental projects as part of these settlements, because under the Clean Water Act, these industrial facilities would be, if they were convicted, there would be significant penalties they'd have to pay. But if we settle, then we can change those penalties into a supplemental environmental project, which we can then, so that lets us send money back into the community. And we work through various environmental foundations around the bay to do things like eelgrass restoration or or sediment monitoring, or things that can help keep the bay a healthier place. Another case I did was a industrial gas manufacturing facility. This was much more outdoors. You can see, hopefully you can see that, there's a lot more surface area where, stormwater might collect and wash off, but same general principles, right? They self-reported the data, was clearly in violation. We settled, we got a big treatment system put in that treats all the stormwater that comes off of this site. And we settled, and we got a supplemental environmental project for the community, and and then we also get fees. We get reasonable attorney fees, so all of our time on these cases is compensated at the end, which is a big bonus for Baykeeper. And then jumping from the stormwater context to direct discharge context, this case just recently. We just recently sent our notice letter, and we've been getting some press on it. But there's a petroleum coke loading operation at the port of Benicia, and we got a tip on our pollution hotline that there were big clouds of petcoke dust every time they were loading these ships, and that, as you can hopefully you can see, there's petcoke in the water drifting around as well. So, under the Clean Water Act theories, that would be a direct discharge. The point source in this case would be the nozzle of the petcoke loading crane, which sort of just shoots petcoke into the hold of the ship. And the pollution is obviously with petcoke, which has a lot of harmful chemicals in it. It's a petcoke, short for petroleum coke. It's a derivative of petroleum refining that gets used. They burn it in power plants. So these ships are loading up to go to Asia, and it's much like coal. I think it looks a lot like coal, and it burns a lot like coal. So it's used similarly. And at this facility, there's a refinery run by Valero nearby, and they load the coal. They load the petcoke into rail cars. Take them down to the silos. You can kind of see the silos in the background in this photo, and then load the petcoke onto the ships from the silos. These are some more photos of some of the pollution getting into the water that we documented. So this right now is at the notice stage. We've only just sent our notice of violation, which is required under the Clean Water Act citizen suit. You need to give the facility 60 days to respond, and you need to make sure that the government agencies are not doing any sort of their own enforcement. You have to give them a chance to do their own enforcement. We never really run into problems with government agencies stepping in and trying to take over a case, but I know other people have. So it's always sort of a tricky situation, but the way we're handling it now is we're publicizing it now, and we're going to try to hold them accountable from the beginning. So this is a really exciting case. Under our notice letter, you can see we're alleging that petcoke is directly discharged during loading, and they have no permit for this facility. And then just real quick, I'll wrap up in a second here, but we've also used this for for concentrated animal feeding operations. We've also done Clean Water Act suits and settled cases, sort of cleaning up some of the CAFOs around the bay as well. And I will wrap it up there and send it back to Professor Reiter. Thank you so much.
Great. Thank you so much, Ben. That was really interesting and wonderful work that you're doing. And investigating with kayaks and drones is fascinating. So now we're going to head over to Michael, and we're going to hear a little bit more about ocean noise pollution. Michael, I think you're on mute.
So yeah, thank you,
Perfect.
Professor Reiter. I appreciate this opportunity here. I don't see my share screen tab here, but I do see myself. And I see also it's about a 2-second or a 1.5-second delay. That's interesting. Anyways, thank you, Ben. I really appreciate the work you're doing to keep this bay clean. We're living on the same bay here. We're up in Marin County. You introduced this idea that pollution was something you put in, some stuff you put into the water that was not there in the first place. And this is easy to really define from a chemical standpoint. But we worked for a couple of years to try to get noise introduced into the water as a pollutant under the United Nations Convention on the Law of the Sea. And it's a very lugubrious body to work with, but it took us about 2 years when we finally got noise pollution identified as being a pollutant, something that wasn't in the water in the first place. And that's helpful, but under the Clean Water Act, this doesn't really apply. So a lot of the work that we do typically is a policy component of under the Marine Mammal Protection Act and under the National Environmental Policy Act in terms of transforming the environment in a way that is deleterious to the habitat.
So why don't we go ahead to John, if you're ready, if we could go to you, and then Michael can work on his end on the tech side of things. So we'll go ahead and have you give an introduction to the work that you do. And again, we've kind of framed this in terms of our collective water. And this part will be really interesting because it's a little bit closer to home and on the freshwater side.
Great. So can you hear me?
Yes, we can.
Okay, good. Just want to make sure. So my name is John Groveman. I am the Policy and Water Program Director for a Vermont-based environmental advocacy group called the Vermont Natural Resources Council, or VNRC. And that's my dog. I apologize for that. And VNRC, we're the largest statewide environmental group in Vermont. We have a water program and a sustainable communities programs and a climate and energy program and a forest program. We do a lot of work in the legislature and with the regulatory agency in Vermont. And also I'm a lawyer, even though I'm the policy director. And we do bring lawsuits to achieve our goals. So I was asked to talk a little bit about farm pollution issues in Vermont, and hopefully my dog will stop barking. So I do have a PowerPoint, and so I could try to share it. So why don't I just run through it, and I could email it to somebody if somebody wanted to, but I'm happy just to run through it. So farm pollution in Vermont. So farming in Vermont, for people who, and the VLS people are in Vermont, it's integral. Farming is just generally integral to the economy and the culture and the sense of place in Vermont. So it's very important endeavor in Vermont, and it keeps our working lands along with our forests. We want we really like in New England and in Vermont to have our working farms and our forests surrounded by our villages. So it's very important, to Vermont. But the real challenge has always been, and it's come into clear focus over the last, since we've had the Clean Water Act in particular, but especially in the last 20 years, is farming does pose threats to natural resources in Vermont if it's not conducted sustainably. And so we've really wrestled with a lot of farming issues in Vermont. And I thought I would talk about some of the 4 largest areas of farm pollution that we're really grappling with right now in Vermont. Have to do with water withdrawals, discharges to waters, wetlands, and pesticides. So just starting out with water withdrawal. So farmers use a lot of water. And they use it for irrigation for crops, and they use it for their livestock. And in Vermont, we've seen recently with the legalization of hemp and now cannabis, but people have been growing, farmers have been growing hemp in Vermont for a while, for at least 3 or 4 growing seasons, and they use a lot of water. So it's heightened the sort of issue of the water that they're taking from both groundwater and surface water. And in Vermont, and I'd be interested in how other states fare in this regard, farming has, because I think its importance as industry and to the sense of place in the culture of Vermont, it's exempt from almost all environmental regulations, either completely exempt or treated differently, more, gently from a regulatory standpoint. So about 10 years ago, Vermont created a groundwater withdrawal reporting and regulatory program that also declared groundwater to be a public trust resource. Farming was exempt from that program, from both reporting and the regulation, and the public trust aspect of farming. Farming was considered basically to be a public trust resource because of its benefit to the public. So that's kind of a good example of how farming gets treated more favorably in Vermont. Surface water withdrawals in Vermont, we don't have a statewide surface water withdrawal program, and that's where a lot of the water for the hemp farming has been coming from. So I'm on a legislative group committee right now, a committee that was formed by the Vermont legislature, along with other stakeholders, including farmers. We're actually working with the Vermont Law School on this, trying to create a broad surface water withdrawal program in Vermont. And the testimony that we've had from experts is that farming should not be exempt from the oh shit. Did I just do that?
You're still with us.
Oh, I am. Okay. Sorry about that.
Yep.
Because I can't see anything. All right. It's good to let me know.
Right.
Thank
You
yeah.
That farming should not be exempt. So that's the kind of the
so we're
consensus,
fighting to
like.
create a reporting program and a regulatory program that includes farming. It would be the first time that a recommendation like that was made. So we'll see how that goes. I think the group, with the exception of the farmers on the group, are going to vote in support of a report that recommends the farming be included in this new program. So then the other issue that we're grappling with is discharges to waters, and we talked about a little bit earlier with CAFO permits. So under the Clean Water Act, it's illegal for farms to discharge to surface waters, but you can do, and obviously whole courses are taught about farm pollution under the Clean Water Act, but the legal definition of discharge under the Clean Water Act is vexing and has been used in Vermont, and I would argue across the country, to make it difficult to address discharges from farms. To be covered under the Clean Water Act, for a discharge from a farm, you either have to be what's known as a CAFO, a concentrated animal feeding or operation, or have a direct discharge, or be discharging to a water that doesn't meet water quality standards that listed on the Clean Water Act, what's known as the impaired waters list. And if the farm discharge is causing or contributing to the violation, you could pull the farm into the Clean Water Act in that way. But we have for years in Vermont, a lot of the farm pollution is farmers basically they fertilize their field in the spring, load it up with manure and nutrients, and then it rains, and that all washes out into surface waters. And in Vermont, we don't have farms that are generally large enough to be CAFOs. CAFO is based on the size of the farms, the animals that are being kept, and how they're being kept. And there are about 19 farms in Vermont that qualify as CAFO out of the hundreds of farms that we have. So that runoff from fields that I just described is exempt from the Clean Water Act as stormwater, but it causes really huge problems, and we really grapple with that. To be a direct discharge from a farm, you have to have a direct conveyance, a ditch that's running through the farm right into the receiving water. We've had a couple of cases where we've been able to prove that those conveyances meet the definition of a discharge, but they're few and far between in terms of the farms that we have in Vermont. It's mostly the situation I just described. Similarly, in Vermont, we're really wrestling with something called tile drains. Farmers use tile drains to drain the farmland so they could farm it. If it's too wet, they can't farm it. Often they're draining wetlands when they do that. They could be causing direct discharges. We're having big debates in Vermont about where the tile drains are. We don't even really know where they all are, and are they direct discharges? So we spend a lot of energy on that and less energy in successfully dealing with that pollution. The other way that we're able to get farms regulated, though, is, as I mentioned, they're discharging to a polluted water, and somebody's talking, so it's making it a little bit hard. People can hear that, but those Lake Champlain, Vermont's probably most well-known water body, is polluted with phosphorus, and farms are discharging nutrients with phosphorus to the lake. And so we've been through the Lake Champlain total maximum daily load, TMDL, have been able to require more of farmers in terms of water quality through what we call required agricultural practices that address how much nutrients are being put on the farm, and cover cropping to reduce erosion, and keeping livestock out of waters, having riparian buffers. And so those regulations have increased as a result of the Lake Champlain pollution and the TMDL. But in our opinion, at VNRC and other environmental groups in Vermont, they're still weak. There's still not enough to really deal with the full scale of the farming problem. In some segments of Lake Champlain, farming is 80% of the pollutant load of phosphorus, and I think it's at 40% in the part of the lake that, that is more polluted with stormwater and wastewater. So we continue to grapple with that and look for ways to, get at that pollution. Two more issues with farming. One is wetlands, which I mentioned briefly with tile drains. Farming can have significant impact on wetlands. As I've mentioned, that farmers need to drain wetlands in order to farm the land. They've done that historically. There's been a lot of wetland loss on farms. Farming is partially exempt under Vermont wetland rules, and we've been locked in a battle for 5 years with farmers trying to expand that exemption. And we've been trying to expand the regulation of wetlands. Farming is not exempt under the federal law, Army Corps of Engineers regulation of wetlands, but you need generally an acre or more of impact to fall under Army Corps of Engineers regulatory jurisdiction, and most farms in Vermont don't meet that trigger. And the Army Corps doesn't have enforcement mechanisms, and their permits are not as strong as the state permits. So that's something that we're dealing with right now, and then we expect we're going to see in Vermont proposals to weaken wetland regulations for farms, and we're going to battle that out. And then pesticides is something that we're really grappling with in Vermont and farming. For years it's been documented that farmers using pesticides has been contamination of groundwater and drinking water and surface waters. Pesticide regulation is the agricultural agency in Vermont runs the pesticide regulation program, and they, in our opinion, are pretty lax about it. And we've had evidence, and we've tried to move to ban certain pesticides that we found in groundwater and drinking water that are known to be so toxic that they shouldn't be in use, pesticides that have been banned in Europe. But we just have not gotten anywhere. And we continue to advocate for the banning of certain pesticides and better regulation of pesticides. And lastly, I think this is the biggest issue facing farming and pollution, and just actually farming, and as it's going to exist in terms of being something that is in Vermont and remains part of our sense of place and culture, is what is having sustainable farming, both economically and environmentally. The farm economy in Vermont is in crisis. We lose hundreds of dairy farms, a year. The market for milk and milk products is completely It's not a free market. It's controlled, through these strange governmental mechanisms and the Farm Bill. Farmers just can't keep up in Vermont. The demand for milk doesn't exist. And it's very expensive to farm. And so they go out of business. And we take actions in Vermont to try to prop these farms up, often farms that are polluting and experiencing the pollution problems that I mentioned. So, we've been fighting to try to get a conversation going in Vermont, and the conversation is going, but it's too slow, in our opinion, to talk about how do we have economically and environmentally sustainable farming, transition off traditional, especially dairy farming, that is not making it economically and having significant pollution problems in many cases. We want to maintain the farming landscape in Vermont. We want that land open and working. We don't want to see it turned into houses and subdivisions. But, it's very difficult to turn the ship because people have been farming the same way for almost 100 years. And a lot of the ways they're farming has been actually either mandated or promoted by the federal government, and in ways that were not smart economically or environmentally. So we're trying to define sustainable or regenerative or organic farming, and use government money and regulations to move farming in that direction. So
thanks, John. I think that's actually really
said.
great to transition back to Michael, because I think that he's going to speak a little bit about offshore wind, I believe, as part of his presentation. And so this theme of sustainability, in a changing climate as we move forward, I think will be a really important point. All right, so we're going to hand it back over to Michael. We are running a little bit behind, but there is a break and snack session at 3 p.m. and the next panel doesn't launch until 3:15. So what we're going to do is have the next two speakers go, and if the students are interested in staying on, we'll run beyond the break as long as our tech host says that we can make that happen. All right, over to you, Michael.
Okay, thank you. Can I be heard? I can't be heard.
You are heard.
Oh my. Okay, good. Just want to make sure. Vimeo is at the bottom of my list right now. I'm going to try to share screen and zing through this as fast as I can. And what we're going to do, we're going to open this up here and window. And we'll do this one and share. And I'm going to do this slideshow from the beginning. Okay. Can you hear me as well?
Perfect. We can hear you, and we can see the slideshow.
Okay, good. So I'm going to try to zang through this one here. As I mentioned before, Ben talked about introducing stuff into the ocean or into water that was not there in the first place as being pollutants. We're talking about sound, which is not really stuff, it's energy. And the energy pollution stipulation that we were working on with UNCLOS, United Nations Convention on Law of the Sea, had to do with their concerns about radioactivity as being an energy pollutant. But we managed, hammering it out over a couple of years, to have noise or sound included as an energy pollutant, because the ocean is an acoustic environment. Much like the terrestrial environment we are in is a visual environment. Animals in the ocean rely on sound. And this has to do with the fact that if you get a few hundred feet deeper at nighttime, it's dark. So you can't have everybody go to bed. They have to basically communicate, and they have amazing adaptations. And I'm going to try to run through some sounds that animals make here briefly. If you're in the shallow water, you're going to hear, let me hear if you hear this.
Yes, we do.
Okay, that's snapping shrimp, and they are ubiquitous in shallow waters, and they actually provide what is called acoustical daylight. It's a sound field that when it bounces off stuff and becomes coherent, animals in the ocean can see it, much like the sunlight bounces off of the stuff that we see. And so that's, and then these other animals, this is mantis shrimp. They form long 20-year relationships, and these are two mantis shrimp purring to each other, courting each other. And then if a healthy soundscape of a coral reef will sound like this. So you hear the snapping shrimp in there, but you also hear these other animals chortling and what have you. And that is, that's a healthy ocean. Different animals have different sounds for different purposes. These are midshipmen. They are shallow water intertidal animals. And these are two males trying to persuade a female that they're the best. And these are silver perch, basically trying to do the same thing, except it's in mass. Okay, and we all are familiar with the sound of the humpback whale. I'm going to overlap some of these sounds here. What's amazing about the humpback whales is the males sing these songs, and they all sing the same song. And so in terms of a breeding fitness announcement, which is something that you typically ascribe to some kind of morphological behavior that is kind of genetic, they all sing the same song. So, what are they doing? And they've only been figuring this out for the last 6.5 million years, so we're not sure ourselves. This is a minke whale. We're not sure exactly what this call's about. And then we have the carpenter fish, aptly named by the old whalers, but these are sperm whales, and this is the social gathering and aggregation. And you can hear why they're called carpenter fish, because they sound like journeymen. Orcas are also a very social animal, and this is the sounds that we hear are the ones that they're social sounds for these animals. They also use biosonar, which we can hear as clicks and pops, but we can't really hear the details of that. So one of the things that we know about these animals is that they don't have symbolic language that they use, but they have names that they use for each other. And we're trying to figure out, how do they portray hunting strategies, because they hunt in packs and they hunt strategically. How do they convey that to each other? There's some informed speculation about that, but there's very little way you can kind of test those hypotheses having to do with, for example, being able to project images to each other through their biosonar. Okay, so we got into this mess back in 2017, where the administration was basically being controlled by the oil companies, and they were going to open up oil drilling on all the coasts here. So I'm a marine bioacoustician. I come out of biology and physics. I work a lot with people who are in the legal trade. They're policy folks, and a lot of the work that we do is trying to figure out how to get under the hood of stuff like this and stop it. And we managed. It took 4 years. We were basically stomping out grass fires for 4 years, but we managed to not have any leases come out around the coast, and the oil leases. And why is oil leases a problem from my standpoint? Because right here are the survey maps that they were going to do. These seismic surveys are incredibly noisy. And they were going to do not one to find out what's there. They were going to allow these private companies to come out, and they had 11 different surveys. And the surveys dragged these air guns behind their boats, and they blast off every 10, 15 seconds. And and these are kind of survey ships. And they basically hit the sound that goes down into the substrate and kind of gives them a read as to what's down below. But it sounds a little bit like this. It looks like this. Okay. the dulcet strains of air gun blasting, and literally every 10 or 15 seconds around the clock for months on end. And this is obviously problematic for all these critters in the ocean, which use sound as their way of establishing their relationship with their surroundings. And then once they actually get these things together, they start drilling, they have these deep water pre-refineries, and the soundscape changes from what you heard in the coral reef to this. Delightful. Okay, so we managed to kind of put the plug on the oil and gas guys. We now are looking at wind. Pivoting to wind is a great idea because every watt that's generated through wind is not generated through fossil fuel. And we know fossil fuel is killing the planet. But it is a balance of harms argument because wind also has its problems. These are the East Coast, Gulf, and the West Coast proposals that are basically running through about as fast as possible right now. We've been dog paddling since June to try to get EIS's comments and recommendations and what have you. And again, I'm working mostly with legal people, so I'm kind of a biological input to the law folks, and I really appreciate their expertise because they do policy, they statutes, or up to the elbows in this stuff. But in the Atlantic seaboard, there's 30 different proposed wind farms that are up for discussion right now. And all of them have their various different problems, whether it's North Atlantic right whale, benthic invertebrates, fishing grounds. All these are basically interferences with existing habitat and commercial uses. And so there is no lack of legal expertise that's going to be needed to tap dance through these 30 on the eastern seaboard. And what's the problem? So when they put eastern seaboard is shallow water, so they essentially have these various different ways of anchoring or mounting these masts. The most common is piles of some sort, and they drive these piles into the mud. And what does that sound like? Or the bigger ones. And again, this is stuff that goes on around the clock, and it is disrupting everything from the invertebrates all the way up through the marine mammals. So marine mammals, there's protection. The invertebrates, there's not. We have to look at it from an environmental standpoint. How is it modifying the habitat in a way that the invertebrates are being compromised at the bottom of the food chain that essentially is going to impact everything from fisheries to whale feeding to what have you. And then when we have the masts in and the turbines blowing away, this is what it sounds like underwater. So that was just one turbine, and that is a 2 megawatt turbine. This one is a 14 megawatt turbine, the largest right now. And you notice all these little munchkins over here who are getting ready to launch this thing. That's going to make a little bit more noise than that little 2 megawatt one. So we're transforming habitat in really significant ways, just from an acoustical standpoint, let alone from a structural, physical standpoint. So one of the things that was found is in the North Sea, they have these langoustine, which basically fluff up the mud. It's bioirrigation, and they fluff it up in such a way that the annelid worms and all the other kind of amphipods and what have you can reside in the mud there. It's fluffy. But they found that the noise stresses them out and they don't fluff up the mud. So what's going to happen in the North Sea as that mud settles and becomes essentially hard as concrete is all those critters at the bottom of the food chain are not going to be able to inhabit it. Okay, now we're changing fisheries up there as well as, the life for this poor little critters. So we're transforming stuff here. California, where I reside, we have deep water It's not shallow out here. So we have another situation where we have these spar buoys, semi-submersibles, but they're all floating, and they have these anchoring lines that are keeping them in place there. Okay, so we're turning what is open water for the last millions of years into a forest of spars and cables and ropes and what have you. Why is that a problem? Because the area off here is an upwelling that is really rich in nutrients, and so we have a lot of whales here that feed on this stuff, and they essentially. Okay, so here's a little picture of this stuff and the cables and blah blah blah. Bureau of Ocean Energy Management has this clever little snappy video of how the whale goes down and essentially feeds among these things. But what they're missing is that these animals are lunge feeding, and they don't just kind of chew like cows, and they actually lunge at their food like this. And you notice the lower jaw is open like 90 degrees. Okay, what happens when this animal that's traveling at 6 meters a second, which is about as fast as you can kind of just run, not sprint, but run, hits a cable? Does that jaw fall off? It's like if you were running and all of a sudden ran into a lamppost. So we're concerned about this stuff. So other operating concerns are the operating noise, surface vessel noise, because they have surface vessels going out all the time, increase in ship strikes, bird propeller strikes, of course, also electromotive force. We're finding, for example, crabs aggregate around and they're kind of hypnotized by the wire, because electromotive force is coming off the wire. And the barometric noise impacts on bird migration is another component of this, which I'm concerned about, and it's just coming up essentially that birds navigate using pressure gradients. For example, barometric pressure. They when a storm's coming in, they have a high pressure zone coming in. They know that's happening, and they'll rise up in front of that and use that storm front to actually navigate in front of the storm and get some mileage off of it. Well, when you have these giant propellers, literally 1,000 feet tall, out here, modifying the kind of barometric pressure of the area, is it can confuse these birds. We already see that shearwaters avoid offshore wind by 20 kilometers. So obviously something's going on there. These are some of the things we don't know about, and it's a balance of harms, and here we go. Oh, and this is the other thing I think we all need to know. This is kind of use metrics over the next 50 years or up to 2050. And the sustainable stuff kind of takes up a little bit more. But if you notice, the line on top continues to go up. So we continue to use more energy. As long as we equate energy use with economic growth, we're going to have this problem. We have to use less energy. So that's my evangelism here. So thank you very much, and I hope that was informative.
Thank you so much, Michael. It's really, really fascinating. So I'm going to just be really brief and hand it right over to Jackie so that she can do her presentation. And fingers crossed, we will have some time for questions. If not, I'm coordinating with Carolyn right now to see if we can get all of the speakers' emails, just in case students will need to submit their questions via email. All right.
Thanks so much, Sarah. And I am going to go as speedy as possible so that we have time for some presentations. So apologies in advance if I'm speaking too quickly. But my name is Jaclyn McGarry. I'm the manager for the Global Ghost Gear Initiative at Ocean Conservancy. In my day-to-day, I manage a lot of our projects around the world, helping to identify funding opportunities for some technology trials or for some gear retrievals, and really supporting capacity building with our partners around the world. I want to thank some of my colleagues who have let me borrow some of their talking points today. Given the nature of this panel, I wanted to really showcase kind of the breadth of Ocean Conservancy's work on the ocean plastics issue. And so I wanted the first half of my presentation to be kind of about plastics at large. And then in the second half, I'll kind of zoom in and narrow in on our work on ghost gear. So I am hopeful that I will be able to share my screen. Share that. And hopefully you can see that okay. So Ocean Conservancy, in case you're unfamiliar, is a nonprofit. We work to protect the ocean from today's greatest global challenges. And together with our partners, we create science-based solutions for a healthy ocean and the wildlife and communities that depend on it. We have offices in Washington, D.C., Alaska, Washington, Oregon, California, Texas, and Florida, and we do work around the world. And relevant to many of you students here on the line today, we have over 120 professionals, including, attorneys, ocean scientists, policy and outreach experts. So while I'm not an attorney, I do work with many of them. And best of all, we have, a really robust network of members around the world, 160,000 members, as well as 1 million online activists who help us to achieve our goals. We really work on a lot of systemic issues facing the ocean and in the key geographies that are under threat. You can see that we work on everything from climate change to sustainable fisheries, ocean planning, protecting the Arctic, and then of course our work on trash-free seas, which is what I'll be sharing with you today. You probably know that plastic pollution is one of the biggest threats to the health of our ocean. Today, we've talked about a number of different forms of pollution, but one of the things that makes plastic really unique is that in most cases, though not all, it's highly visible. It's an impact to marine ecosystems from kind of the deepest parts of the ocean all the way to the shores of every coastal country in the world. New research estimates that the global annual emissions of plastic pollution into all of our rivers, lakes, and the ocean globally is a stunning 24 to 35 million metric tons, which is about 3 times more than the estimate from just 5 years ago. So we're really starting to get a handle on how big this problem is. That weight is equivalent to roughly 9 Eiffel Towers worth of plastic entering the ocean every day. At Ocean Conservancy, we've been working on this issue for more than 35 years. And so one of the things that really sets our work apart is that we approach this issue in kind of a multi-pronged way. And we really want to tackle this problem from every single angle. So we work both upstream. So how do you stop this problem at the source, with the development of new plastics? And then downstream, how do you position communities to address this issue kind of at the local level? We have kind of 2 really ambitious goals. The first is to stabilize ocean health against plastic pollution by 2030. And the second is to mitigate and prevent the largest and most damaging pathways of ocean plastic debris. And in order to get ahead of this plastics crisis, we really feel that as a society, we need to kind of fundamentally rethink our relationship with plastics and restructure the plastics economy. So in order to get there, our kind of 3 main buckets of work fall under reduce, manage, and cleaning up plastic. For reducing plastic, we are committed to reducing and ultimately eliminating unnecessary single-use plastics. Unnecessary being the key there. I think we have figured out that as a society, there are some plastics that we will never get away from. In some cases, I think about like the medical industry where there are single-use plastics that are required. But how can you start thinking about the things that just truly don't have a place in our society, like single-use plastic bags? So as part of this effort, Ocean Conservancy is a key environmental advisory partner to the Beyond the Bag initiative, which launched last summer. And it's looking at how to reinvent the retail bag. Studies show that nearly 100 billion single-use plastic retail bags are thrown away in the US each year. And they're consistently among the top 10 items found on beaches and in waterways during our global cleanup, the International Coastal Cleanup. Over the next 10 years, we're also working to make sure that we manage 75% of the plastic waste produced so that it doesn't enter the ocean, and maximize the potential for these materials to be recycled. About 11 million metric tons of plastic flows into the ocean each year. You heard earlier, I quoted the 9 Eiffel Towers. That was for rivers, lakes, and oceans. So just oceans, 11 million metric tons each year. And a lot of this is from mismanaged waste streams on land. Larger cities are a major source of this too, particularly in developing economies where economic growth outpaces infrastructure development. And so in 2019, we launched our Urban Ocean Initiative to engage cities in the fight for clean seas. Cities are home to more than half of the world's population, and they have a really important role to play in reducing ocean plastic. So this platform works to improve municipal waste collection and waste management systems, as well as kind of embedding these core tenets of plastic waste reduction into, other city plans and efforts as well. The third pillar that I mentioned is that cleanup. That's something that Ocean Conservancy is no stranger to. We have been partnering with organizations and individuals around the world for our annual international coastal cleanup. And it's kind of become this like beacon of hope and our signature initiative as an organization. Most people who know of Ocean Conservancy and have heard of our work, it's through the International Coastal Cleanup. Since its beginning 36 years ago, more than 16 million volunteers have collected more than 340 million pounds of trash, and it's the world's largest volunteer effort on behalf of our ocean. And when they clean up that trash, they are not just throwing it away, they're also logging it in a citizen science data effort, which has allowed us to analyze trends of what's being found on our beaches year over year for more than 35 years. So reducing and managing plastic pollution isn't just solving one of the most visible and tangible issues facing our ocean, but it also will help us tackle climate change. Most of us don't think of plastic as oil pollution, but we really should be. It's kind of the equivalent of a slow motion oil spill. The plastic that we see in our ocean and on our beaches started out as fossil fuel. And so if you haven't kind of thought of it in these contexts before, I'm going to give you a few reasons why, plastic plays a big role in the climate crisis. The first is that fossil fuel is, fossil fuel and fracked gas is the feedstock for plastic, and it's where plastic comes from. And making that plastic is extremely energy intensive. It burns quite a lot of fossil fuel and is very emissions intensive, pumping out lots and lots of greenhouse gases. Those greenhouse gas emissions from the plastic sector are roughly 2 gigatons annually, which is the equivalent of 370 million passenger cars. So quite a lot of emissions that come from the production of plastics. Third, this industry is growing. We expect plastic production to double by 2040 and quadruple by 2050. And so plastic is this climate issue in a way that a lot of other sectors are climate issues because of their energy use and emissions footprint. And then, of course, you can't forget the human health costs that come from oil and gas extraction and plastic production. And far too often, these operations happen in communities of color and place a disproportionate impact on people who are already at risk. Fourth, and this is pretty important, the plastic that you see on the beach and in the ocean is part of a massive petrochemical industry and built on the fossil fuel industry. So that industry that's driving climate change and is seeing their future for oil production shrinking, and they're going, oh no, people are switching to renewables, what are we going to do? They're seeing their future in plastics. So this kind of global plastic crisis is really inextricably linked to the climate crisis. And so as the private sector and governments invest in clean energy and move away from fossil fuels, a major part of the transition is looking at our connection or our relationship with plastics. Finally, we can't address the ocean plastics crisis without also addressing the threat of ghost gear, which is kind of my comfort zone and my wheelhouse in my day-to-day. Prior to starting my role with Triple GI, I was only vaguely familiar with the term ghost gear. I'd seen photos of kind of coral reefs that were covered by nets, but I mainly thought about the issue the same way I thought about littering. Unlike many other forms of marine litter, ghost gear is often kind of out of sight and out of mind because it's so far beneath the surface. And so I mentioned earlier that in my day-to-day work that I kind of manage our projects around the globe, help to obtain funding for our partner work, and organize the logistics for trainings, gear retrievals, and technology trials. Ghost gear is the common name for abandoned, lost, or discarded fishing gear. I might also call it ALDFG today. And since it's purposely designed to capture and kill marine life, ghost gear is the most harmful form of marine debris. Most of it is made of modern plastics that can last more than 600 years in the ocean, and it continues to capture and kill marine life and fish stock long after its intended lifespan. So how big is a problem that most people have never really heard of? About 46 to 70% of floating macroplastic in the ocean comes from fishing gear. And one UN study estimates that at least 640,000 metric tons of fishing gear is abandoned, lost, or discarded in our ocean each year. Additionally, about 5 to 30% of global harvestable fish stocks, depending on where you're talking about, which fishery, are killed by ghost gear each year. So that means that ghost gear isn't just an ocean problem, it's a people problem because it threatens global food security, coastal communities, and fisher livelihoods. About 80% of animals that become entangled in ghost gear end up injured or dying, and about half of marine mammals that are on the threatened species list have been found to be affected by ghost gear. It additionally serves as a navigational hazard for ships and boaters and fishers as well. It can be caused by direct and indirect causes. So, big storm blows a fisher's lobster pot off of where they originally set it, and when they go back to retrieve it, it's not there. Marine traffic accidentally cuts a rope on a net, or gets tangled with another fisher who's out on the line. And then an indirect cause might be lack of disposal facilities. So, if your net is old and it has holes and no longer works, how do you get rid of it in a way that is not going to cause damage to the environment? The GGI is part of Ocean Conservancy's Trash Free Seas program, and it is the only cross-sectoral alliance committed to driving solutions to the problem of lost and otherwise abandoned or discarded fishing gear around the world. We work to improve the health of marine ecosystems, protect marine life from harm, and safeguard human health and livelihoods. And we do that through the 3 R's. So we really want to reduce the amount of gear that's lost in the first place, remove the gear that's already there, and recycle the gear that's been recovered or at the end of its life through promoting extended producer responsibility. We truly have a global reach with 124 members around the world, as well as 18 supporting governments and 4 high-level global affiliates. We work to engage the industry through raising awareness, having ghost gear action plans in their supply chains, and ensuring that any kind of solutions that we come up with are viable, lasting, and really make sense for the industry. We have 2 documents which we use at the heart of all of our work. These are our best practice frameworks for the management of fishing gear. We have one for wild capture and a brand new one on aquaculture. And then we have solutions projects around the world. So these are active projects where we are kind of testing and gaining new information about what works, what doesn't. Are the things that we preach in our best practice framework applicable on the ground? And so these are always developed in cooperation with our local partners. I just sped through that super fast, but I know we only have like 3 minutes for questions. And so I wanted to try and end as quickly as possible. But thank you again for having me today. And it was great to join you.
Thank you so much, Jackie. So what I'm going to do is have Carolyn send out the panelists emails for questions because I think we're going to be cut off in 2 minutes. But Orion here wanted to say thank you to all of the speakers for the hard work that they are doing to clean up and keep the waterways clean. So do you want to say thank you?
Thank you.
All right. Well, thank you so much again to all of our panelists, and we will have students send questions to you that they may have via email. And next up is the CERCLA panel, which will start in about 10 minutes. Thank you so much.